and final talk of this today's session. So will be held by Matthias Beyer and me. So I'm actually introducing myself, which is kind of weird, but however, I guess we can deal with that. And yeah, we want to talk about why IFM in particular has decided to invest in thin-edge.io and how the project could help us to build smart devices with edge capabilities. And we will basically provide a brief history of IFM as a company, and based on that history and through the positioning of our gateways and edge devices, we want to position these edge gateways and devices in an established categorization we found at the Linux Foundation. There's a working group there called Linux Foundation Edge, so the LF Edge, and we would like to deduct our core requirements for adopting thin-edge.io for our products. And, just want to present this to you and share our thoughts on that. So, during that session, I will also ask Matthias later on a couple of questions in his role as an expert for thin-edge.io just a couple of questions about the underlying technologies and the underlying architectural assumptions, and because I really want to know how they fit to our needs when I have a look on the IFM products we currently have and also we will have in the future. So give me just a second to switch over to the right slide deck, and we'll start with that session right from there. So as already mentioned, Matthias Beyer and me, we're working with IFM. Matthias Beyer in the software development department, and me working as a product manager, taking care for the market needs and creating new ideas and detecting chances in the IoT market with respect to various connectivity topics. So IFM, what is IFM? I really want to make it brief, and I do not want to bore you with any company presentations. But I just want to give you an impression where we come from and why particular aspects of this project are really relevant for us. So this is part of this idea of the whole motivation why we started to invest in that. So IFM has been founded in the late 1960s. Has been based on basically a new principle in presence detection, which was during that day really kind of a brilliant idea. And since then, I've built up a portfolio of sensors with different use cases, domains, and industries. And this is basically still, general still our main foundation and business model. So we're producing really lots of different kinds of sensors for different industries and use cases and domains. And coming from that, after some decades of doing that business and growing, and also being a global player in terms of standardizations and also playing a key role of the introduction of the IO-Link standard, we entered to some extent also the market of industrial communication, because it's quite the usual thing you do. You're coming from the physical world, from sensing and so on, and then go over to providing that information for the network and control on the customer side, connecting the sensors to field buses. And also provide that information, and that was really an important step to complement our portfolio in that direction. And this comprises PLCs for mobile machinery as well, and PLCs and connectivity modules to interface with industrial standards and field buses. So, and then roughly 10 years later ago, we started to invest in the industrial Internet of Things and Industry 4.0. By doing so, we entered this complete new market for us by position IFM as a first step as a kind of data and information provider. So this is more or less here the third column of this step-by-step development of our company. And and to do so, of course, we started to extend our existing products that originally has been designed and optimized for automation and control use cases, with additional features to also provide the measurements and events to support IoT use cases. So we extended the products to not only provide information to the automation and PLC layer, but also to the information systems at the customer side. And currently, we're still already working on the complete end-to-end solutions based on software products. We really have kind of sensors connected to software systems at the customer side, but also in cloud platforms. So this is basically the way we're approaching this whole market of IoT. And yeah, based on that continuum of this edge continuum provided by the Linux Foundation, I just want to yeah, show you the taxonomy of edge computing layers, because it's kind of interesting to position ourselves and our products in that continuum to give you an impression what are our main needs and what is driving us. So due to the history of IFM, we cover the edges, yeah, right, starting from the most left side of the spectrum, which is called the user edge realm here in this overview, in this taxonomy. And in the class of the constrained device edges, IFM provides different gateways and preprocessing units, and those units usually implement the transition between connected sensors and the industrial networks and control layers. So they are specialized to some extent for a particular task to do exactly like this. So we have, for instance, these ionic masters, which are field devices and offer interfaces for field buses and also for IoT-centric access. Another example is that you can see here, it's a vibration analysis unit, and this unit just has this one task to derive a couple of mechanical KPIs that represent the condition of a machine based on more than 40,000 samples per second of acceleration sensors, for instance. So and these devices are mainly driven by microcontrollers without any sophisticated Linux operation systems or similar, and are often programmed in C, and they really optimize to exactly fulfill this task as cheap as possible when it comes to hardware, of course. So then coming over to the next taxonomy, so in the class smart device edge, IFM develops more and more generic hardware platforms that support different use cases. So these hardware platforms usually are driven by ARM-based CPUs, have roughly 512 megabytes or 1 gigabyte of RAM, and provide a full-fledged Linux distribution that has been built for the ARM hardware architecture. And those devices usually run commercial software packages or provide runtime environments for applications developed then by our customers. So therefore, even if the resources may sound sufficient, the computing power needed by the domain-specific software applications often exceed 60 to 80%. So to enable those devices for edge connectivity and device management functionalities, there's often not much of resources left. So this resource constraints are also valid for this class of devices as well. So yeah, one may ask now why IFM does not provide more computing power resources. It's so cheap today to meet the needs of those cloud native development practices that I mentioned here below in that area here down there as in criteria. Yeah, the reason lies in the positioning of the devices in just two markets. So one market is the OT domain. This market is really price sensitive. So that means that the product design is driven by a well-defined use case usually, and the hardware is optimized to support exactly that use case. So the resulting product must compete then with other devices from other vendors, and the resulting price is really critical, a really critical part of this competition. So and then you have, on the other hand, the other market for the same device, which is the IoT domain. And here we cannot really anticipate the concrete use case yet in advance, and to some extent, missing resources always limit the possibilities, right? So more power would enable the devices to support more and more use cases, of course, but this would put risk on the success of the same device in the first place in the OT market. So by making it too expensive, though, it's kind of the pity situation, and this dual use character of those devices for OT and IoT use cases pushes the development always and consequently towards performance optimization. So this is really important to mention here. And yeah, and coming to the last category, so the third class of these on-prem data center edges, how the Linux Foundation calls it, represents usually IPC-based appliances that provide plenty of resources, of course, but these hosts at IFM, at least at IFM, are usually dedicated to run, for instance, in our case, the IFM or Neo IoT software suite for the on-premise use cases. And the main challenge of those edge computers is then managing the life cycle of the whole appliance, so of the underlying operation system and also the applied Moneo modules. So the typical commercial IoT applications therefore need a secure, reliable way, but also a resource-efficient way for device management and for a device management agent that only needs as few resources as possible, just to leave as much power as possible to the IoT application itself. So, and for that particular use case, the main device management use cases are software management, of course. So we really have to react on things that have to be patched on the Linux OS level, which is really important nowadays when it comes to cybersecurity. But it's also relevant to update the Moneo software modules when it comes to bugs or when it comes to regular releases. So, and also, which is also something that we have to take account, is the firmware updates for the connected devices that are connected to the Moneo edge computer. And device monitoring is also really important to get a clear understanding how is the hardware, how is the host going. So with regards to CPU usage, memory usage, and how we utilize the hard drives or the SSDs. So this is also something that's highly relevant because we also use those platforms to store data before we forward it to target platforms. So when it comes now to the embedded development process at IFM, usually it really just starts with an idea coming usually from product management or from sales, where we just detect a particular chance to position a new product in our markets, and going from there, we try to assess the requirement, what is actually really needed by, I don't know, 80–90% of our customers potentially. What is maybe too special to maybe there's a chance to keep it out, and this leads to a product definition, and then usually there's a kind of development project starting with all the different methodologies and spirits and approaches. And in the end, the result of such a project is something that really has to be tested, and the quality assurance is really extensive. Because we always have to keep in mind if we introduce a product in the market, we have to assume that it will be used at least 5 up to 10 years, sometimes even much more longer. And this is something that's really highly relevant for us because this is something that's really important also for our brand, but also for our customers to have something that's really stable and lasts for a long time. And then after that, we have an approval for serial production. And then when it comes to the combination of software and hardware, there's at least one a process that at IFM that defines that the deployment of the software has to be done during production, and this is something that has to be really easy and has to fit in our production processes, which also leads to some requirements on that. So based on all these discussed considerations and background, of the presented taxonomy. We really derived just a couple of sometimes even non-functional requirements that comprise several aspects, like the life cycle of the OT devices, which can be pretty long, the creation of various variants based on one consistent and tested code base. It's really a huge effort to do the tests and the quality assurance for each and every combination of software and hardware. So it would be really important for us to have something that you can just test and then deploy under a particular configuration, then to create a product out of this configuration of the software and the hardware. So because then we have to test the software only once and then derive different products from there. What is also really important to mention here is the increasing and really increasing relevance of cybersecurity for the connected OT products. So we are really looking for approaches that are to some extent secure by design, that we really try to use technologies that really try to reduce the number of vulnerabilities of our products, because in the past, in the last decades, most of the OT devices ran in really protected environments, like production networks that were kind of Fort Knox, and now this well-defined security model gets more and more holes, and the security of the components inside that. In the past, really well-protected area is getting more and more important. Last but not least, we really have to have a streamlined development process, which also leads to have this core principle of one code base and then a configuration-driven deployment. So, and from our point of view, Lineage.io has many of these core concepts in mind as a first-class citizen, and therefore we decided to contribute to that project by developing and providing architectural innovations, and by driving the development of the Lineage.io core written in Rust. And all the requirements, to some extent, must be reflected on the product-centric business model of IFM. So that means that we have to assume that we might hopefully sell edge devices in a 3 to 4 digit number per year to customers that implement the applications on their own. And therefore, we must ensure a high level of quality, as already mentioned. Integrity is also really important, consistency, and also an excellent user experience. Even if it's deployed and configured based on a configuration file, for us it's always important that then the user experience of that configuration is excellent, to avoid from a large number of individual services and support cases. And even worse, we want to prevent also from recalling products, which is can be a nightmare. But so this is something that really drives us, and then therefore we decided, because we see lots of these things in Lineage.io, and we really want to develop it further into that direction to enable our OT products to act and to interact in IoT environments. That's why we're here, so to speak. So but this is all theory, and when it comes to concrete questions, sometimes you really need experts, right? And so I'm pretty glad that we now have all the access to this Lineage.io community, all the different colleagues there, also from other organizations. There's lots of knowledge coming in, and today I want to just ask some questions. So I want to ask Matthias those questions because he's here and he's my colleague, but he also stands for all the other colleagues in the team, just a couple of questions. So Matthias, thank you for having me here. So for being here for us to answer these questions. So I already mentioned it, cybersecurity, something that really bothers and which is really relevant. So what advantages does the Lineage.io design has, or regarding this whole topic. So how do we cover this?
Yeah. So ThinEdge itself is built in Rust. It can be used with other languages, of course, but ThinEdge itself is built in Rust, and Rust has some very interesting properties. So Rust gives you assurance that there is, for example, no seg faults in your code, or you do not access invalid memory and prevents data races. So it's really hard to get things wrong in Rust. And by that, you automatically have benefits for the security because the attack surface of your program is reduced.
Okay, so that's really interesting and relevant for us. So yeah, when it comes to concrete devices, some of our IFM edge devices in this smart device edge category from the Linux Foundation, yeah, basically ARM-based single board computers with industrialized, really robust and so on, but in the end, comparable with Raspberry Pis, with full-fledged Linux distributions. So is it possible to deploy ThinEdge.io or ThinEdge.io configurations on such a device?
Yes, definitely. So right now we are targeting a Linux environment and Debian at the moment. But for example, other Linuxes will also be possible. And right now there's some extra effort involved, but that will be reduced in the future, of course.
Okay, cool. Yeah, I already mentioned it. So there's also this other category of really constrained devices. So some of our gateways will provide platforms with embedded Linux distributions customized to an actual device. So, so what kind of infrastructure, you know what I mean? So this kind of OS layer services are needed to run ThinEdge.io?
So right now, ThinEdge.io relies on MQTT broker and some service manager. For example, systemd that is required for running ThinEdge.
Okay, yeah, got it. So yeah, and we also have gateways and also these Ionic master devices that are driven by microcontrollers without any full-fledged operation system. So maybe more microcontroller related approaches. So for example, an Ionic master is such a device. So and they fall more or less in that category of constrained edge devices, so really constrained edge devices. So is it already possible, so in general, to deploy and run ThinEdge in such a context?
So right now it's not possible, depending on the actual size of the device. So the answer is no right now, but that might change in the future. And if someone's interested, if you are interested, feel free to reach out.
Okay, so maybe it's something that we really have to look on a case-by-case thing. Yeah, can imagine. It's a wide area. Yeah, I also mentioned that with those on those devices there are also several other software applications, and we really try to put there as much as possible and want to scale with regards to connected data sources. As much as possible. So do we need to reserve many resources for ThinEdge.io?
No, so right now we're talking about we're targeting a low memory footprint, which is something in the megabytes range, like 16 to 32 megabytes, and lower is of course better. Wow. And we're trying to be really light on CPU usage, and Rust is definitely one thing that helps us a lot there.
Okay, yeah, understand. So yeah, with this regard, so yeah, we already tried it out with Moneo, the connectivity solution built on top of the Moneo software product. But in general, is it easy to have interoperability with existing services and software applications that are already deployed on the same edge device? Because usually you cannot assume that ThinEdge.io is alone on the planet, right? You know what I mean?
Yes, definitely. So interoperability is definitely key with ThinEdge. And right now, MQTT is the prominent way of having interoperability. And it will continue to be, but other protocols and ways to connect to ThinEdge, will definitely be possible in the future. So as the project continues.
Okay, thank you so much. Yeah, thank you for the answers. So yeah. so many questions, but yeah, can you mention? So yeah, are they